And welcome to Building a Smart Farm, episode 5. This week we're going to be taking a look at how to do real-time data processing over larger time ranges than we had last week. So last week we had our Firebase database containing all our sensor data. We were streaming that into DuckDB so we could do these real-time dashboards. But there were limitations with how much data we could handle with this method because it's all done in the browser. So to try and be able to do things like view sensor data over a month's time range, we're gonna try and aggregate daily some statistics so that we can then just add up so we can get this almost real-time view. And I'm joined again by Gabriel Koch of AgroPatterns fame. How you doing?
I am doing great, Tom. Looking forward to this.
What is the purpose of this data?
Let me talk about temperature and humidity in 3 different contexts. We talked about growing degree dates, which is important to understand when a plant will reach its maturity and it needs to be cut. Second point, we need to understand temperature and humidity for the behavior of the active ingredients that are applied to the plants to keep them healthy. And the third component is temperature and humidity variations to understand pest and disease. Mildew will behave completely different when there's high humidity and lower temperature than for instance, mites. Mites will be the opposite. Mites, hot temperature and hot conditions and low humidity will cause the mites to just grow exponentially. So it is really important to understand historics because we correlate this information with visual ops field. So when we have a scout walking up and down the flower beds and identifying pockets of extreme conditions with mildew, for instance, then we want to correlate that with what was the temperature and what was the humidity in that case of the greenhouse during that week.
Okay, in addition to our growing degree days, and that was temperature based, we also want these other factors as well because that's relevant for pests. I've got last week notebook here, so that was episode 4 when we wired in DuckDB. So we've got, here's our sensors here, here's our temperature, that's still running. And what we did last week is use these SQL cells to build up some analytics, calculating whether it was a healthy growing temperature, and then we summed this up to give us our growth hours over the time range we did. So if we look in the details here, we had we selected data that was greater than a certain start time. And we're going to have to elaborate a bit on this. So first thing we'll do is fork this notebook. And now we're on to episode 5.
I think you're forgetting to the Tarot board.
This is an application built on Observable that is completely white labeled. So we have a custom domain. But if you look at the details, this is actually run from a notebook as well. So this application is completely built in Observable, and it asks OpenAI to do a tarot interpretation. So who is asking the cards? Tom and Gabriel. What question would we like this episode? Got any ideas?
Is it too broad to say if our technology will help with this heat wave? That may be too. We'll see.
Okay, we'll go for it. Will building a smart farm, will our vlog Building a Smart Farm help with future heat waves in the United States? Okay, we've got to pick our 3 cards. Okay, so past, 7 of Swords. The 7 of Swords in the past position suggests there have been difficulties and challenges in the past with regards to heat wave. Yes. The 2 of Swords in the present position suggests that the present situation wanted balance and indecision. The 4 of Wands in the future position suggests that there is potential for success and progress in the future when it comes with dealing with heat waves. So some optimism. It didn't really say whether the smart farm was responsible for that. So maybe it didn't want to be rude and say no. But there is a case for optimism on so hopefully that. Is there a heat wave in the US at the moment?
Well, there's just growing temperatures. It's just what it is, and it doesn't look pretty.
It's roasting in Berlin at the moment. It's super hot. Yeah, so back to our smart farm. So we had our data, we were calculating this growing degrees days, which is the kind of useful thing that we would like to track, but we want to track it over time. We calculated it by looking back a certain time window. I think I even put days to look back. We could edit, 12. So we can look back 2 days. So when we look back 1 day, it was 23 hours growing days. And now, when we look back 2 days, the growth hours is 45. So that makes sense. They've got their greenhouses optimized beautifully at the moment. They're always in the green zone. So our query at the moment, there's a query from however many days you want to look back. What we want to do now is be able to pick a particular day, and we want to calculate the growth hours for that particular day, and we want to store that back in the Firebase database, and we want to be able to go through all the possible days. What happens in practice when you have one of these systems doing aggregations is you change the logic, you want to change the formula, and then you have to backdate it and things like that. So it's good to be able to have a function that just says, calculate me the aggregate statistics for this particular day and save it into the database, and then you can rerun that. Even if you've already done it once, you just want to rerun it. So we've kind of got the logic here, but instead of doing a look back, so the time start ISO, I think that was the time that we started the time window. So we want to just pick a day, right? Let's adapt this work we already did, but make it so that we can choose a particular day. So let's call it the target day, and for now we'll express it in string, and then we need that to be, I think you can just take that day. This might have problems with time zones. I'm not going to get like too much into the details of whether that's a local time and all that. So we've constructed a date object there, the target day, and we also want to take the day before or the day after the target day. Yeah, let's say after. So this is start time, end time is the start time plus 1 day ahead. Does that work out? And then let's do two. What was the technical term? 2 ISO string. New date. So we take our start day and add a whole day. And this is not working very well. How do we get the epoch time? Start time dot. It's one of these in here. I'm gonna have to look it up. JavaScript date get epoch time. Get time method. Christ. Get time. Okay. So start time. Get the time. That's in millis, and we want to add in 60 times 60 times 24. That would be the number of seconds in a day. We want millis. Let's see if that works. Yes. So our start date, we specified that with a string. Our start time is this, the 10th, and our end range is the 11th. Let's go back a bit. Try and select data from the 4th to the 5th of July. So that's reasonably clear. Oh, and then we spent a bit of time last week realizing that these are happier if they're as ISO strings. So we'll also have that as an ISO string, the standard format, because DuckDB can handle that happily, and that's a derivation of that tag. Right. Okay. So these things we did here were all used for figuring out what our query would be, but we've figured all that out now. So really, the only thing we care about is this was all working out. Is our final query was growth hours, and we're expecting, because our greenhouses are nearly totally efficient, that it should be a number a little low below 24 hours, but not by much. And where the time is greater than the so previously we had the time start ISO, but now it's start time ISO, and that's taken a long time to run because it's a lot of data, I think. And we want time is less than end time ISO. Oh, we're not in JavaScript land here, it's and. Okay, and it's thinking about it now, I think. Or it had some errors. Probably. Okay, so that's the right query. But the problem is we've not loaded that data. So the data we were loading in come from Firebase, and Firebase was doing a query starting at the time start. So now we want to, time start should be the start time, and we don't want it to run forever. We want end at the end time thing. Should, fingers crossed. So that this cell is thinking about it. So it should be filling up the database now. Insert into. I don't know if those queries returned any data. Let's try and debug this on its own. So we'll get the DB, we'll issue a query, and then we'll call .once, and we'll just get the whole value. Once on the value, this will return a snapshot, and we want that snapshot to be the resolution of some promise. Resolve with the snapshot. So now we'll get to see what the result of that is. Well, that was quite fast. Can we do val? Null. So if I get rid of the end time, is that the mistake I did because I just introduced it? Yeah, okay. So what's start time again? Yeah. Oh, sorry. Yeah. If you remember, if we look at our Firebase, which one is it? Agro patterns. Is it?
Yep.
Yeah. So our historical data of sensors, when we look at one of the real ones, it's a timestamp. So because I just changed it, this start time is in this format. So we want it to be get that. That's got a few too many zeros by the looks of it. Yeah, these are shorter. So it's that divided by 1,000. So the start time should be that divided by 1,000. And that should be that divided by 1,000. Yeah, here we go. So that's got a big block of data. Great. So that's been debugged. This is what I love about these observable notebooks, right? You get stuck, and in this kind of exploratory programming, you can just do just in a cell next door, and it speeds up these kind of issues so much. We don't want it. Right. So we figured that out. Okay, great. So that hopefully should have loaded the data now. And it's calculated our growing degree days as 23. So this is gold. So let's move this back up here. So what happens when we change this to a different day? So I'm going to change this. This was looking at the 4th to the 5th, and then when I hit enter, it should. Well, I don't know what will happen. Let's just see what happens. But I'm expecting that number to change. I'm hoping. Yeah. Look, you can see it counting up as it's streaming in the data. That's interesting. So. Yeah, interesting, because last week we wanted to do real-time charts. We were doing a real-time query with a start date, but we were expecting new data to arrive in the background, so we made it all streaming. This doesn't make sense for this kind of back aggregation. We should only run the query once all data has arrived, so no longer do we expect it to, we don't want it to be a streaming query anymore. We want this to be a like a one-off thing. So actually, I'll leave this here because it's kind of interesting as the streaming one. We might come back to that, but for our core database function, it would be nice to know when it's finished, because we need to wait until it's finished to know when to save it. So really this has to be, we'll just do it as a fresh one. This is the problem. So this is the streaming part. This is useful. What should we call it? Aggregation sensor data. This just has to be executed once for a value query. Get a snapshot, and this becomes the value of this. Promise resolve. Yeah, we really have to figure this out properly. And we'll get the snapshot, and we'll resolve that to the snap.val. Okay, so that gets us all our value. The other thing we did, we were actually filtering to make sure that each sensor payload had a temperature in it. So when we look at all these payloads that come in, it's in the body, that's got battery. This one just says Y. This is what we don't like. So we need to do the filtering that we did here. So we get the snapshot val, that's an object. I'm too ambitious to try and do this in one go. So we call this the aggregation sense data raw, and we'll take that data, and now we'll do the filtering. So first, this is the other thing I love about these notebooks is dividing a problem down into separate cells. So we can view that as an array of entries, and the thing we need to filter on is based on this value. So we've got the entries, we want to filter, and the entry comes in as an array of size 2 with a key and a value. And we want to filter based on the values body. The value body has a temperature. So we did it here by, the data.body.temperature. So that's all we need to do is say it like that. Let's see. So at the moment we've got 164 rows. When we execute that, we've got 92, and the body has a temperature. So that's done the filtering, but now it's in that silly, oh actually no, that's probably an okay format for us. Let's I don't think we need this timestamp. So we'll also map similarly. They arrive as a key value thing. We don't really care about the key, we just care about the value. So that's our data set. So this was the raw one. We started with the raw one. Now we'll call that our main data set, the aggregation sensor data. And we don't want this one going into our data set anymore. So I'll deliberately create a syntax error here. And now that'll help me figure out, per row data processing. Now, the way we inserted data was for every element, we called this data handler, did the filtering, and then it sent it into the flow queue. So we just want to do that exact thing again. So we'll insert into DB. So we want to take all these sensor datas for each one of them. So this is an entry. We want to let's call it data, as that's what it was called before. We want to send it in. So fingers crossed when I execute that, that'll end up adding more data in. Now that's what happens when we reset it. When we reset it, data went in there. Are we sure? It couldn't have come from our streaming query because we broke that, I think. And we haven't got any more. Let's just test it again. So what we're expecting is this one to start executing this cell, which does our batch insert when we reset it. Yeah. And we know that when this finishes, all of these, right, I'll tell you what we could do is I'll show you when we execute this thing returns a promise. So what really comes back is a load of promises. So if we take all those promises and do promise.all, this cell should not resolve until we've inserted all the data. So if we reset it now, didn't return the promise.all. Yeah, this is now holding. Yeah, if you look at when I reset this cell now goes gray, it stays gray. Now that means when this cell has finished evaluating, all of our data has been loaded into our database, and we've calculated the growing degree days from our target day. So change this, while this is computing, this is updating, and then it's done. So this is basically what we need to do, right? Now we want to find out what that value is. So this, I believe, this cell is called aggregation. So if we call aggregation, it has, because this is SQL and it's normally expecting to talk about result set, number of things. So it just happens that we've only got one row. But so row 0, this is really an array. Aggregation 0 is our answer, and it tells us our growth hours. So growth hours. So that's cool. Now let's call this growth hours equals that, and we want this cell to update after we've inserted everything into the database. So we should have a data flow link here. And now when we reset it, it asynchronously loads it. Oh, and I forgot to return it. So if I load it, it's computed. Obviously that was the same number. So if we do a different day, it loads it and computes it for that day. Cool. So this is, so now we've calculated our growth hours aggregation. Now what we want to do is stick that back in the database. Now I think, oh yeah, look, we already had one aggregation D. Oh yeah, we did it last week at the end. Oh good. So we'll write that aggregation. We needed to sign in anonymously. We go into aggregation GDD query sensor name. The date will be the one we chose. Should we do it in milliseconds, or we'll do it in milliseconds just so it's a bit more compatible with the other schema we had. I'm tempted to save it with a key like that, but I think it probably makes better sense to. It will complicate our lives elsewhere if we keep changing time formats. So I think we should do the start date in milliseconds, but how do we get that? Start time, get time, but that's got too many zeros, so divide it by 1,000. So that is the key, I would say. So we'll, at that position in the database, we'll set it to the latest value of our growth hours aggregation. Growth, let's see if this works. Unterminated template, correct? See what? Okay, so that said it executed, and we've got to look up our sensor. What sensor are we looking at? Dev 393, Dev 393, this one. What's that? Yeah. Okay, so we had some old ones. Actually, this has been running in the background since last week. Yeah, so it has been computing stuff that we did last week. So that's interesting. Before we were saving, yeah, I think this GDD for that device at that particular timestamp. I'm just going to delete all these. They're very good at the moment. So delete everything. And now we'll write that aggregation again. Now it should reappear. Yes, so now it's reappeared. We've got clean data, and that's doing our aggregation. So what do we need to do to generalize this? What we would like is to somehow, and this is a generally useful technique, is to take this kind of, the way we've done it at the moment is I've hardwired this target date. So every time I change that, the notebook executes the data flow one cell at a time. Some of these are executed many times, but it does the reactive data flow thing, which ultimately ends in another write occur. What we want to do is turn that into a function that we can just call like we would in normal coding. And the tool to do this is to wrap this all in a flow queue. So I call this process function if and this is for aggregate. So the tool for converting between like functional interfaces and observable data flow idioms is the flow queue. We've used the flow queue in a few places, but this is like a different way of using it. Or it's kind of the same thing, but like you might not have thought about it. And we'll call this an aggregation request. Equals a new flow queue, and we have to give it a timeout. Milliseconds. We want that to be a big number. And instead of going from a target day, we're going to say the target day should come from the aggregation request.target day, right? So this is all frozen now because this has not resolved yet. The queue is empty, so the value of the top of the item is nothing. The inner value of that view, the value of that view is undefined at the moment. It won't be defined until we call it. So we want to turn this into a function. So let's call it aggregate, and the parameters we want to pass in is this target day. Let's just start with that. And when we do that, what we want to do is the whole thing, the flow queue, we want to send it a payload which includes that target day. Okay, so and then we want to return the result of that. Sometimes I say this should be async. Maybe that's a bit clearer what's happening then. And now this turns into a function. So aggregate target day, and now we can call it like a function. So before we were doing it in this kind of data flow way. So far we've got 1 and 2. So let's try 3 and seeing what happens. When we execute this, it calls this function. This function enqueues an item, and then it goes through the data flow, and it should compute it. Let's see what happens. Oh, cannot convert undefined to none. So the incoming, so something's gone wrong. Let's trace where it went wrong. The flow queue aggregation request, when we looked at the top of that queue, it's got this target day, so it's doubly nested, which is probably the issue. Oh, because this is, we're not supposed to put it, this is how it, so if I do that, nothing happens because the queue crashed, so it could never finish it. So in order to reset the queue and do it, we have to reevaluate the queue. That will clear the state of the queue. And now it's starting to insert and it's done it. So this all went successfully. And we've got a third row in the database. So that's cool. So now we can just call aggregation. And what happens if we get the fourth day? What happens is nothing, because the way these flow queues work, you've got to tell them when the processing's finished. So the actual processing finishes after we've written the aggregation. That's when we've finished the job. So this is return result to flow queue. So this should run after the aggregation. We want to the view of aggregation request, and you have to look at the API, but it resolves. It's a bit like a promise. So we want to resolve, and we can pass it a value. So I would say the only sensible value that we can return how that went. So it doesn't like it because I've just executed a few times, but I saw some data fly past then. So I think it actually ripped the fourth and then. So that unblocked the queue and then it executed the previous one. At this state now, I think nothing is trying to run, nothing is frozen. The last time it returned undefined, but now, because I'm hopefully resolving the actual growth hours, I would expect this, when I call aggregate, let's try it again. So let's tick forward a day. I would expect aggregate to now return exactly what the growth days were for them, as well as adding another row to the data. So that's my expect. Let's see what happens. I execute it, it's thinking. This resolves 21, and 21 was written to the database. So now we've converted like what was an observable like data flow style to this functional style that we can just call nilly-willy. So that's, that we've now abstracted all that work we did last week about like figuring out, doing it exploratively. We've now captured that into a function we can just call, which is handy. So that's like the building block for automation. The other thing we need to do is pick the sense. So we were doing the sensor name. So I think we need to abstract this. Let's have a look, because at the moment we're just writing into that one sensor, but we've got 4 sensors we wish to aggregate. So in addition to the target day, we also want the sensor. So that should be passed in here.
Now we may need to take into account some of the sensors have not run every single day. So would that create a problem? I think 2 of our 4 sensors that we have here have been moved from one place to another because of pilots that we're conducting at the moment.
Yeah. So this is all like details that complicate it. Like obviously for the business application that needs to be solved. For now, let's just ignore those details. Yeah, I'll be careful not to hit a sensor that has not got any data. Now we want to be able to pass in the sensor as well. So, we could do this in different styles. Actually, I personally usually like putting everything in a single object, but I'll continue that. So we send the target day, the sensor. We've got the target day here. Sensor equals aggregation day. Look, we get autocomplete on these things as well. Sensor, yeah. So the sensor's now passing through it. I think what we need to do, where do we load the data? The aggregation sensor data. Oops. Where did we define that? Command J. This currently queries by sensor name, so we want to change that to the sensor. Well, actually, aggregation request dot sensor. Okay, that's executed. But what we want to be able to do is call that in our aggregate. So the new one we've got is, what is it? Query sensor name. Actually, I tell you what, we can just pass that in here. That's cool. So this now executing and has it out of memory. DuckDB ran out of memory. Now we were just changing its jerking it around a little bit and not resetting it. So I think if we reset it, it should fix. But what we want to be able to do is just reset it automatically. So every time we do a new aggregation request, we need to reset the DuckDB client. And we've got this. There's a mutable reset here. So I think that's all we need to do is call mutable reset first. So before we do the aggregation, reset it once. Let's see what happens now. Well, I don't know. This one's confused now. Oh yeah, no, it did run it 16 hours. Yes, yeah. So only 16 hours of this sensor on that day. We can't look back in time on this yet. But yeah, cool. So now we can pick a sensor, pick a day, and it will give us the growing degree days on that. So what's the next stage now? We need to backfill all this data. We know the ones that we think do work. What is it? Current. Where are the options from this? The latest, the object.keys. These are our sensors. Is there an easy way I can grab just those names? Yes. So let's have a new function, aggregate all, and it will just in a loop. So the first one didn't work. Let's get rid of that one. That's the cursed one. For each of those, for a particular day, we want to device aggregate day for that device. And now we don't need to worry about so much here. So if we go back to our first of the month, let's see what happens. Because it crashed, our queue seized. Remember, we had that issue at the problem. We need to reset the state of the queue. Yeah, now, I don't know if you saw that, but things were flashing forwards and backwards. Yeah, so our third sensor's inserted for that particular day. So that was it. This flow queue was just seized. Let's try again with a different day. So we'll aggregate all for the 4th. See what happens now. Yeah, 1, 2, and then this ran out of timeout, maybe increased timeout. So I think, how many this is, looks like a big number, but maybe it is. So now there's 2 rows on everything. Yeah, work. Yeah. So on the first, so we're queuing 3 things, and then we should expect this flow queue to pop out 3 requests. 1, 2, 3. Maybe that was 2 and 3. It still looks like it's inserting. Yeah, now it's finished. Yeah. Now everything's got 3 data. Awesome. I'm going to change what this returns. So I'm going to take the result of that aggregate and map it back. And the reason for doing that is it returns 3 promises. What we want is to, again, wait until we've got all of those things done. So we'll do a promise.all and return that. Now when we exit that, this now takes a long time to execute. When it finally does finish, it's got the 3 GDDs for the 3 cents. We could probably, maybe it would make more sense to have them indexed by the device name. But for now, that's fine.
Tom, let me ask you, the screen is a little blurry for me, but the numbers are different in all 3 cases,
yes.
Right?
Well, the first 2 are exactly the same, but the second one of them's the way that.
Well, they're at different locations.
Yeah.
But let me draw back from the business case or the need in the field is that let's say that you have the same variety and it's growing into different. You have to aggregate the flowers, not the bits, but aggregate the flowers in order to sell them to the same client. Well, the flowers in one greenhouse are going to mature faster than in the second in the greenhouse, correct? Yes.
Yeah, well, if they're different temperatures, yeah.
Exactly. So that is why this is so useful. You may have entire farms dedicated to growing maybe 2 varieties that they have to sell at the same time because that's when Valentine's Day is. The day doesn't move, but really the maturity of the flowers differs based on the temperature in the greenhouse.
Yeah. So what we want to be able to visualize is how these growing degrees days change over time for the different places.
Exactly. And in the future, what we're going to do is we're going to have a deadline. A greenhouse or the varieties in the greenhouse must have achieved a number of growing degree days, and then just move back, and you really have to be very vigilant and how these conditions work inside the greenhouse, so that you make sure that you have the perfect flower or the perfect plant to be cut on a specific day.
Yeah.
And this really applies to all types of perishables, right? You just want to make sure that they mature according to when you want to distribute them or whatnot.
So there's and then we can apply this to also the pest thing that you were talking about. We can, instead of aggregating just on like this complicated SQL calculating what happened per hour, we can also be, making summary statistic for the day on, what the temperature highs and lows were and what. This is all useful stuff.
And I think we really, obviously, these episodes are very tech heavy, but it would be interesting to see if our community or the observable community would be interested in making an analogy, talking about flowers, but and we can talk, this probably applies to a lot of crops as well, but it'd be interesting to see if this type of flow applies to, industrial processes or whatever people are doing, because this could be a generic type of data flow that could be useful.
Yeah, exactly. Yeah. So it's quite common that people need these aggregations in their database.
It is different, but it's very practical for our use case, because we can change the ranges.
Yeah, exactly.
The low and high.
Yeah, you can imagine as time goes on, you're like, okay, well, I somewhat arbitrarily put growth degree days as being greater than 5 degrees Celsius, but once we actually see what's happening in the field, we're like, well, actually the plants don't seem to grow until it's 6 and things. Like, we can calibrate our system in the field.
Exactly.
What would you like to do now? Should we push on with visualizing some of this data?
I want to do it right now. I'm happy to do whatever you think.
I mean, I will probably push on, because the Lambda architecture is 2 pieces. There's one bit which is the batch processing, which we've, sketched out now. And then the other side of it is streaming, which we kind of did last week, but you've got to put them together. So what we really want to be able to say is what's the growth degree days in total right now. And we will use our historical data to be able to quickly, add up what happened from yesterday backwards in time. But then we still need to integrate it with the real-time data so that we can have a real-time chart that is tracking sensor data as it comes in. So the Lambda architecture is really 2 parts. We've done part 1. We could try and get part 2 done as well now.
Happy to. I'm here for the direct call.
Yeah, okay, let's just do it. Let's do it. So
right.
I will very quickly backfill this. So what are we on now? We're on the 12th. So this should hopefully put us the last 12, calculate the 12 days of July. Right, it's thinking. Yeah, I think it's thinking. Yeah, we can see it inserting data. Yeah, it's still inserting data. Yeah, okay, so this is chugging away at the moment. We can see it updating in real time. So that's pretty cool. So it's doing all these SQL queries that we, figured out, and now it's just putting in. We can leave that to think about. Now we want to think about the other part of this Lambda architecture. So let's see if so first of all, we need to get the historical data out now. So we're in this GDD location. To build the real-time view, we've got to take that historical data and combine it with the latest real-time data. So let's try and quickly do this. Right. db ref gd. This gets all the data, and that returns snapshot, and we will want to resolve that. That. And this is a promise that takes a resolver. So this should do a query on our GDD location, which came back nothing, because it's aggregations / GDD. So our ref is aggregations / okay. So this is now all our historical data. This is our history. Now we might want to perhaps window it by time. Actually, thinking about it, I've done this the wrong way around. What we want is GDD with timestamp first, so we can do a window selection. I won't bother re-architecting that quite yet. But yeah, really what you'd want to select the window. We can't do that because we did it the wrong way around. But that's our historical data. Like before, history raw. Now let's tidy it up. Object. So we'll get the entries of that history data, and we will. So now it's ended up as an array of 3 elements of the device and all the readings, but the readings contain everything we need. So really what we want to do is just get rid of all these outer things now. So how do we do that? This is our historical data. Now it's arranged in a way that we can access it a bit easier. It's now a single array, and each array, this is the tidy data paradigm now. And this is our historical. So now it's in a nice form, we can do a plot. So let's do a line chart based on historical data, where the X is timestamp and the Y is GDD. Whee! So this looks cool. I think what we need to do is say that the X is type time, and I think maybe this timestamp probably have to put it through new date, and our timestamp was divided by 1,000, so I think we have to say timestamp. Okay, so now it shows us it in proper date. What we want to do is, at the moment it thinks it's just one continuous line of data. What we need to do is have it into we need a line for each device. So I will have a quick look. Observable plot line chart plot line. Here we are. And they got an example one with lots of things. Yeah, here's one with lots. And they did it with the marks. The line was X, Y, normalized, and the stroke was the symbol. Actually, should we do that? I think that's a better way of doing it. Not said, they did stroke. Yeah, there we go. Cool. Two sensors have exactly the same data, but then a difference in the middle here. That's interesting. How does that happen? And then they sort of converge a bit. I wonder if they ended up getting moved into the same greenhouse or something. Anyway, new questions emerge. Yeah, and this is our growing degree days. So each is a daily roll up, and then this gives us how much, that growing degree days expressed as hourly. So in many days it was nearly at 24. We can fix all this stuff. So the Y domain 0 to 24. Is that how we do it? I always forget these ones. Yeah, there we go, 24. Right, so that's nice. So that's our historical data. There's quite a lot of it now, which makes me think that backfill may be successful. Yeah, look at that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 days backfill. Yeah, I think that's correct. So this is the batch part of Lambda architecture. And now the other thing we want to do is now join it onto the latest data. So that's the historical data. Now we want the streaming data. And we will, so whereas this was a promise, and actually this is beginning to look very familiar to what we did before. So I wonder if we can just steal that code then. If we're going to do it one row at a time, we might as well use the code that we had tested. So that's why I saved this. So our latest data, it will look a bit like that. Let's latest row. Generators observe. If it's reset, we'll recompute it. The data handler does the filtering. We're querying by, and for now we'll just hard code it to that one. The start time is today's seconds. There is no end date because we want it to update when new data continually arrives. And the reason why I wanted to reuse this is when we create this query, this is a streaming query, it takes up resources, and then when this cell reevaluates, you want to get rid of those resources. So we also deregister it when the cell invalidates. So this is a bit more sophisticated, that keeps our resources under control. So when we execute this, what's happening is this is executed loads of times. Let's call this all latest data equal. What we want to do is get this into one big result set. So there's a variable called this, which refers to the previous value of a cell. So if this equals null, that means it's never exited. So our data so far equals either this, if we've got one, otherwise we'll create a new data set, and this data so far we will push every time new data arrives into it, and then we'll return the data so far. So this is a little trick for, adding up stuff. So at the moment it's just 1. If I rerun this query, Oh, it's only done one. I would expect this to fire. Oh, wait a minute. This is even sending it down the data line. We don't want that. So every time we execute it, it adds one, but it's the same one, right? It's not a new one. Data so far. What I'm going to do is debug it. Actually, I don't care about debugging this. What I want to debug is this streaming query. Why on child added, call the data handler. So I'm expecting this to fire lots of times for the whole data set from today onwards. So let's see what happens. The latest row executed once, and then when I let it run again, that other one triggered, and it fired. That was it, just one. Data handler. Oh, I know what we can check. Let's rerun that again. So the debugger, let's see what this data looks like. I wonder. So that data is correct. From the history sensors, the snapshot, if we look at what snapshot came in, snapshot key was undefined. Well, that doesn't seem right. Starting at today's seconds, 1657, 1657, and undefined. So it's picking up this one. Oh, for some reason, this is historical data. Maybe this sensor turned off. Is that what's confusing me? Because there's no, the timestamps only go up to 1657 and, oh no, 1657, 58, 57, 58. Yeah, we haven't got numbers this high. Is this maybe one day too far? What happens if I go backwards? How did we calculate this? Today's seconds is now. Yeah, we definitely truncated it. This should be correct. This should be correct. So, why is it not correct? Unless we're getting bitten by time zone or something. Let's try a different, let's see if another sensor has more data. So that was this one. I think this is the one we usually pick.
The 9.3 should have.
This one's got more data. This one's definitely got more data. Yeah, there's tons more data. Okay, there was, I think we just picked the wrong one. So the one we like is that 393. What was it called? Query sense name. That's the one. So our latest row, let's go from there. Still only one result for 9.3. Does that make sense? This is right. 8647. Yeah, that looks like it should be right. And the last row is 165764. Today's 165758. So yeah, I'm definitely expecting more here. So let's see what happens when we execute this query manually. We get once, we hit it, and if I hit play, yeah. So it's firing lots of times. That's good, but I think maybe it's firing so rapidly, this only evaluates one. What we need to be able to do, what I want is a cell that will have all our latest data, and when a new data point comes up, we want to redraw the graph. We have to redraw the graph from scratch anyway. So when a new data point comes in, I want our current data set, to increment, to be recomputed, and then we can just draw a graph of it. Now, last week we sort of put everything into a SQL database and graphed it that way. To save time, I'm trying to avoid having to go through SQL. So last week we were quite good at every time new data arrived, we were inserting into a SQL database. So that kind of handled the problem of loads of data. We're gonna have to think about doing it a little bit different. So what will happen when new data arrives? This will still update. The problem is when we first issued the query, this updates so fast that Observable's internal sort of deduping logic, or keeping the animation snappy logic, will sort of realize that this is updated, and it will just compute at once at the end. So I think we can fix this. So this basically works. So instead of sending it the data, I'm going to say the row. I'm going to send an object called the row. Like what I was doing here, I'm going to try and retrieve what I'm going to try and do this aggregation internal to this. This will work better. So the total is either this or so we'll have, if there is a this, if we do have a previous value, the total is this dot. If we don't have a this, all is a fresh array. So this total, we'll call this data set. Yeah, okay. So our data set On initialization, it'll be nothing. Otherwise, we pull it out of ourself and we will notify the data set will be, turn the data set there. And every time new data arrives, we will push to the data set this new, right? And we're missing a comma as always. So this is thinking, has it crashed or something? Is it in a weird loop? Or it can't notify. Is there a bug somewhere? Let's see what happens. If I, where's my debugger? If there's a body data set, what's data set? In the closure, the data set is an empty array. Oh no, the data set's ended up. Sorry, yeah, there's a programming bug there. So the data set will be an array, otherwise it's what's in. And we push in the data set. Right, does that work? Yes. Okay, so now it executed. So we did something clever in that before we were just returning a single row each time, and we're still doing that, but we're also tucked in a cheeky way of aggregating it over time. And if we waited for 15 minutes, more data would arrive, this data handler would execute, and this data set would increment. So we're sort of doing in the incremental and batch sort of in one row, in one go. So we call this the latest data. Right, and that gives us the full data set, and we've got the historical data set. So let's have we'll probably call this raw. And the data set is presumably not in a useful latest data, not in a good format. So the latest data should be our raw data set, and we want it to align with the kind of data we had here, which was object device timestamp as a date object, growth degree. Damn. Oh, I don't want to compute that growth degree. Well, that's going to be, yeah, we do need the SQL for calculating the growth. Forgot that. Let's skip over that detail. We will take our latest data set. So we could put this all into a DuckDB and then, compute everything from scratch, which is what you should do. For now, in order to get something work this second, we will just put some dummy data in. So our data set is an array. For each entry in the array, we want to normalize into the format that aligns with the historical. So we need a device, was the entry.device, and we need a timestamp, which was the entry when, how many digits? I think that needs to be times by 1,000. And we need the GDD. It's not the GDD. Each new measurement is really just the temperature. Temperature, right? Yeah. So now we've got the latest data is the device, the timestamp, which needs to be in a date. Yes. So yeah, starting at midnight on the 12th onwards, we've got the temperature. But we don't want it. We don't want the temperature. We want the total. We want the total GDD per device, so we can have this. So what this graph is missing is what's happening today. So we need to measure what the GDD so far of today is, and it's out of 24 hours. So we have to sum up all these temperatures. We have to do the same mathematics we did, so we could reuse it. It's just a bit complicated, like tactically, for me to pivot and do that now. So what I'm going to do, we need to take all this data and reduce it, fire a reducer function, starting at 0. The accumulator has an row. How do we calculate it? So our row, so we need to return our new total. So this is actually GDD. So we need to take our previous GDD and add in the row.temperature. Right, this is not correct. We did it correct last time, but doing it correct is a bit fiddly. Okay, yes. So now we're adding up the temperature, but oh, wait a minute. If the temperature is greater than 5 and not there. So we want to take the growth degrees so far. If temperature is greater than 5 and row.temperature is less than, what was it? 25 or something. Our green bars, 28. No, well, I'll do it to these ones because these are my reference ones. So if the temperature is greater than 5 and less than 25, if that is true, we will increment it by 15 minutes because the sensor's collecting every 15 minutes. 15 minutes is 0.25 of an hour. Otherwise, we say no. So I think this should be a very crude approximation. Yeah, 17.5. So that's about right, probably. really we should be grouping it by device, but because we only did a query for one device, so latest data growing. So our latest data is really the device. Well, we hard coded that. The timestamp. Oh yeah, and we're working on granularities of a day. So it's really the day set, new data today's, and the GDD is the late, right? And that's a date. Okay. So the timestamp for the 12th, the GDD is that. We should keep an eye on that. 17.5. When new data arrives, this query will update. All of this should update, and we should see that creep up. And now the idea of a Lambda architecture is you fuse, this is a real-time stream, this will update in real time, and we fuse it with this historical data that was using this batch process, and then we'll end up with a chart that actually reflects the very latest state of the farm. So at the moment we're doing historical, so I think we can probably just concat the latest data onto there. So at the moment, well, let's see. Yeah! That was hard work, that one. But there we go. So now we've got an extra day plotted on the end. Obviously, we only did only one of the device, but that is the Lambda architecture running, I believe. Ta-da! We're missing a few little parts, right? So we've got this function called aggregate data. What we need to do is every day call this function, and maybe we call it if we haven't already computed it or something like that. But so there's a missing piece. I did the backfill manually in this function here. We would have to auto that. There's a gazillion different ways of automating it. It's definitely less complicated than ingesting real sensor data. So we could create a web code endpoint here that merely calls aggregate all, and we could call that endpoint using an off-the-shelf, cron solution or whatever to just call it every 15 minutes. Like that bit is the least difficult thing to figure out. But if this thing is called regularly, we'll always be writing into the database the daily totals. So this part of the history will get updated automatically over time, and then this bit, I mean, we've explained how to do this. So this should update automatically as data arrives. Okay?
All right.
Okay, well, thank you for listening. So I am again on holiday next week and the week after. So the next stream won't be until 3 weeks' time. And I think what we should think about is the putting this notebook into production. So as you can see, there's like bugs, things can get broken. It's quite easy for things to start failing. So if you actually want to run this in the wild for real, we need additional tools to make sure these notebooks are running. We need monitoring, we need these cron jobs. So I think the next stream we'll just do a lot of miscellaneous tidy up. Things I've been ignoring so far, like Firebase security rules, monitoring for health of the system, that kind of thing. We'll do that plumbing. I think that's generally applicable to many different situations, right? So we want these notebooks in production, and so the next stream will be about these kind of productionization topics. If anyone's got any particular questions about that, then email me, tweet to me, whatever, and I'll try and address all the miscellaneous stuff in about 3 weeks' time.
Okay, Tom, and I want to finish this episode by mentioning that they can also contact me. We have some big plans in the future for this technology. If there's a need to find out more, I'd be happy to join in.
We are building a smart farm.
More importantly, though, is that we are connecting IoT devices and using this methodology. And I think it's for people that are working with IoT devices, this is a very viable and a very quick solution to get data, not only in a testing environment, but also in production.
Yeah. Yep, and all production topics will be fleshed out very soon. So thanks for joining me again, Gabriel.
All right. Thank you, Tom. And I have fun in your during vacation. I will be holding down the fort.
Okay, brilliant. I'll speak to you soon.
All right. Take care. Bye.